We're on the last module of Module 8 now. This is going to be Lesson 5, which covers three-dimensional figures. And this one, the textbook actually claims, is going to be a single-day lesson. There's a mere 10 resources in it, and you know, I'm even going to skip over that entrance section because I'm just so excited about getting done with this entire module. So, from there, let's get started on our learn. A polyhedron is defined as a three-dimensional figure or solid with flat surfaces that are polygons. Prisms and pyramids are going to be types of polyhedron, and polyhedra is a plural form of polyhedron. Our next definition is a prism. A prism is going to be a three-dimensional figure with at least two congruent parallel faces called bases that are polygons. The prisms are named by the shape of their base. So example, this is going to be a rectangular prism here, this is going to be a triangular prism here, and these are also going to be polyhedrons. Next term is for a pyramid. A pyramid is going to be a three-dimensional object with one base that is a polygonal and the other faces are triangles. Pyramids are also named by the shape of their base. So here I've got a rectangular pyramid, and right here we have a triangular pyramid. And that's kind of a funny shaped triangular pyramid, isn't it? Now, the polyhedron, I want to go back and revisit this and talk about what is not going to be a polyhedron. And the answer to that is going to be a cylinder, because a cylinder does not have any flat faces to it. It only has a flat top and bottom, but the sides are not flat faces, therefore it is not considered to be a polyhedron. From here we get to pick up some more vocab terms, including we have face, we have edge, we have vertex. Whoops, let's get that again. Let's try and get this working right. There it is. And we have vertices, which are going to be 4 different definitions you're going to see on your upcoming quizzes. First thing we have, we click there, that is going to be a vertex such as H, where the 3 or more faces of the polyhedron intersects, and vertices is a plural form of vertex. Now, you see the pointy thing here. On a polyhedron, the pointy part, that's going to be your vertex. Right here you have a flat surface. That flat surface is going to be a face. It has no depth to it at all. It has to be perfectly flat. Unlike y'all's faces that are kind of lumpy and stuff, the face of a polyhedron is going to be flat. And then the edge is just like the edge of a knife. It's where two sides come together to make a sharp edge piece here. Not a corner. The corner would be the vertice. The edge is where just two sides come together. Now going back and talking about things that are not polyhedrons, we have a cylinder. A cylinder is a three-dimensional figure with two parallel and congruent bases connected by a curved surface. And you can see the cylinder here on the left-hand side. And then a cone is another example of a three-dimensional figure that is not going to be a polyhedron. It's defined as having one circular base connected by curved sides and a single point known as the apex, not the vertex, the apex. So let's identify some stuff here about whether or not it is a pyramid, or whether or not it is going to be a polyhedron. In the first row, select different three-dimensional figures to compare and contrast their features. So first off, is this a prism? The answer is yes, it is going to be a prism. It's not a pyramid, cone, or cylinder. This one here, it's going to end up being a pyramid, as you can see right there. They already had it labeled. And so from there, is it going to be a polyhedron? Yes, both of those are going to be polyhedrons. Next, what shape is a base? And both of them have a polygonal base. Next question is going to be, how many bases does it have? Well, the prism has 2 bases, those 2 opposite sides, while the pyramid, it only has 1 base. And then from there, how many surfaces does it have? Not how many surfaces, right here, the number of bases. Nope, I already talked about that. The number of surfaces here, you got flat surfaces are all polygons for the hexagonal prism here, and for the rectangular pyramid, you've got surfaces that are all going to be triangles. So in this case, these polygons, they're also going to be rectangles. Now for example 1, we want to take and find out how many faces, edges, and vertices there are going to be on each one of these figures. So we've got a rectangular prism as the first figure we're going to look at. And if you count them all up, the number of faces, look at, they're going to give you pretty green things going there, is going to be a total of 6. It has 6 faces. Good. From here, we're going to take and look at the number of edges next, and the number of edges, they're taking and counting them out, and it's a real common mistake here that people miss these edges on the sides right here. So the total number of edges is going to be 12. You got 4 around the top, 4 around the bottom, and 4 connecting the top to the bottom. That's going to check as well. And then finally, the number of vertices, you got 4 vertices on the top and 4 vertices on the bottom, and you can see in the video while those are going around for a total of 8 vertices. Easy math. Anybody can do this stuff. Now you take a minute and pause the video and work this one on your own. So what do you come up with? For me, I see 1, 2, 3, 4 faces because it's got 3 sides and a base for a total of 4. Edges are going to be 1, 2, 3, 4, 5, 6. So we've got 6 edges. And then vertices, we've got 1, 2, 3, 4, or 4 vertices. Check it. Easy math, folks. Another definition we have is plane. A plane is defined as a flat surface that extends forever in all directions. And we also have a cross section. The intersection of a plane, a solid and a plane, is called a cross section of that plane. So let's take a look at this video and see what we're talking about here.
Cross sections of 3D figures. Describe the two-dimensional shape resulting from a cross section of a sphere. Make a slice through the sphere. This is called a cross section. The sphere may be sliced horizontally, vertically, or diagonally. The two-dimensional shape resulting from the cross-section of the sphere is a circle. Describe the two-dimensional shape resulting from a cross-section of a cube. Slice a cube horizontally. The result is a square. Slice a cube vertically. The result is a square. Slice a cube diagonally. The result is a rectangle. Describe the two-dimensional shape resulting from a cross-section of a cylinder. Slice a cylinder horizontally. The result is a circle. Slice a cylinder vertically. The result is a rectangle. Slice a cylinder diagonally. The result is an oval.
Well, that looks pretty simple. I think that's a very good way of demonstrating what a cross-section is and how you can visualize those in your mind as you're looking at different shapes. Now, for example number 2, they are giving us a square pyramid, and they want us to take and describe the shape resulting from a horizontal cut of cross-section and a vertical cross-section and an angled cross-section. So let's take a look at those. First off, we're going to take a look at the horizontal cross-section, and we will find that out by sliding across here, and oh, nope, that's going to be a vertical cross-section right there. And when they do the vertical cross-section, what do you see inside here? I end up seeing a triangle. So you got a triangle right there. Check that, and it checks. Next, we're going to take and return the slider back where it belonged. So we did that, and we're going to take and drag the next one to find out what the horizontal cross section is going to be. And what do you see right here? I see a square. We're going to check that one. That checks. And now we're going to reset that back to the center. And now we're going to take and do a diagonal cut across it. And you can see right there they did a diagonal cut right here. And what did we get? I am seeing a trapezoid is what it's going to be. check that answer, and that checks too. So you can, depending on how you cut this square pyramid, you may get a square, you may get triangles, or you may even get a trapezoid. For extra example 2, we have a cone, and they want to know what shape are you going to get when you cut that cone right down the center? Well, the shape I'm seeing is going to be a triangle, because if you cut it straight down, what you're going to see from the side view is going to be a nice perfect triangle. For example 3, they've given us a rectangular prism, and they would say describe the shape resulting from a vertical cross section, a horizontal cross section, and a slanted one. Well, let's see what they're going to give us here. Maybe we'll have some more cool toys, and we do. First off, we want to see the vertical cross section. For that one, they've cut it up and down there, and what do I see? I see a square. That one, wait a minute, maybe they're going to call that a rectangle? Let's see here. Yep, they're calling that a rectangle. I guess it is more rectangular than squarish. Now we're going to take and reset it, and we're going to do the middle one for a horizontal, and what are we going to get? Well, we're going to get ourselves another rectangle. Check that. And then finally, we're going to take and do the diagonal one, and on the diagonal one, what are we going to get? We're going to get, yes indeed, it's going to be another rectangle. So for this one, it doesn't matter how you cut it, you're going to get a rectangle every time. And for our last problem, we're looking at extra example 3. When you cut this across, just like they showed it, what's a cross section going to be? Well, it's going to be a rectangle. Check it, and the answer checks. Easy math. I think you're going to find this is a pretty easy homework assignment. Y'all get started working on it so you can get good, easy grade for a change. And I look forward to answering any questions you have in class tomorrow.